Hello, I'm Bob Guthrow in the Data Product Marketing Group at Pivotal. And today we're going to look at how advanced analytics deployed within a massively parallel processing database like Greenplum can be used to detect and fight synthetic fraud. So how big is the problem that we're talking about? Well, estimates vary, but conservatively, synthetic fraud costs the banking industry about $17 billion a year and represents 10 to 15% of banks' unsecured bad debt. And banks are typically experiencing about 100 to 200 synthetic fraud accounts per million annually. So this is a significant problem for the financial industry. Now it's important to draw distinctions between types of fraud. The one most common, and hopefully most of us have not directly experienced, is third-party fraud. It's called that because it involves stealing another person's account or identity. There are three parties: the cardholder, the bank, and the criminal. The criminal wants to smash and grab as much as possible before the fraud is caught, either by detection algorithms or because someone reported it. The last part is important. With this type of fraud, there's a victim who can spot and report the fraud. Most third-party fraud is caught this way. The other type of fraud is first-party fraud. It's called first-party because the perpetrator and the victim are the same. This is important because it means there's no one with a motivation to report the crime. The criminal opens accounts in their own name or creates a synthetic identity borrowed from other people. For example, somebody may take one person's social security number, one person's address, another person's name, or a slight variation on their name, and use that to create a false identity that doesn't map to any real life identity. This is becoming a more common way to commit credit card fraud. Synthetic fraud is an example of the first party fraud, which is what we're talking about today. One reason why synthetic identity fraud works is that by US law, any credit request submitted to a credit reporting agency will open a credit file if not existed prior to the request. So fraudsters will create a synthetic ID and build a credit profile by directly applying for credit with a lender, such as a credit card issuer. The initial application may be declined, but nonetheless, a new credit file will be established as a result. Therefore, a synthetic identity resembles a person who is a new applicant for credit. The criminal is allowed to complete the application process because the synthetic identity meets the lender's criteria for a thin file, no-hit prospect. For example, a first-time applicant like a student or a recent immigrant. Banks typically rely on a social security number for identity verification. As long as the social security number does not raise any red flags, the credit application with that number will be approved. To get things started, perpetrators typically target credit card issuers that offer lines of $300 to $500 to applicants with no history. By maintaining a good credit history on the starter account, the criminals can quickly begin to open new lines of credit that will later be harvested. Identity theft has a particular consumer victim, and there's a much higher likelihood of the fraud being reported to the financial institution as a result. People look over their credit card statements for suspicious transactions, for example. Current algorithms are designed to fight third-party fraud, and they rely a lot on time series analysis, looking for unusual transactions compared with past purchase behavior. More sophisticated algorithms can also bring in geolocation data as well. So for example, if you are in the United States, but your credit card is being used in a foreign country, most banks' algorithms will pick up on that rather quickly. Meanwhile, synthetic or first-party fraud is harder to detect by traditional fraud algorithms, which are basically assuming the existence of a third party in the transaction. Whereas with first-party fraud, there aren't any unusual transactions. There's a synthetic ID instead of a takeover in account. The consumer is not the victim and will acknowledge unusual purchases. So let's take a look at patterns of synthetic fraud. So most of these types of fraud follow a bust-out pattern, where the perpetrator systematically increases the spending limit of a credit line by paying off small purchases. The goal of this is to mimic normal account behavior and build a credit profile that can obtain ever larger loans or credit limits. Eventually, the fraudster will maximize or bust out the entire credit line, running up large balances or loans with no intention of paying them off. To maximize the damage and harvest, sometimes criminals will make overpayments with a bad check in the final stage, which inflates the credit limit and again maximizes the losses. It's relatively easy for a first-party fraud criminal to continue what looks like their normal historic behavior while planning to bust out. Therefore, issuers' typical fraud detection systems may fail to identify the high risk on these first-party fraud accounts. Synthetic fraud can also be the original intent when the card was opened, or the perpetrator may methodically build up credit for a future score. This type of fraud is not unique to credit cards, because deposit account overdrafts often tap lines of credit related to the deposit account. First-party fraud and credit abuse also work well for criminals via checking accounts. Some of the typical indicators might be very high credit applications in a brief period, or a large number of credit line inquiries in a brief period. We'll have more to say on this on the next slide. So as we indicated, there's a number of different characteristics that can be combined in sequence parse to form detection signals of this type of synthetic fraud behavior patterns. By analyzing transaction activity, payment activity, and non-monetary transactions, lenders can quickly and accurately restrict future authorizations or suspend suspect accounts. Now, given what we know from our previous slide about the patterns of fraud, some of these indicators make obvious sense, like the number of credit lines or the number of credit line inquiries, or purchases that happen to be liquid, or for materials and goods that are easily fenced. Abnormal metrics here can signal intent to commit fraud. The focus of analytics on first-party fraud is different from third-party. There's an emphasis on prediction rather than detection, and the data and analytics stack therefore looks different. The other thing that's important is that while third-party fraud algorithms also incorporate notions of geolocation information, as we said earlier, they're primarily based on time series analysis. That is, they compare the current behavior with the past behavior. That's not feasible if you have a synthetic ID with a thin history. So if we're analyzing fraud, well, what type of methods or algorithms might we use? Well, fraud detection is a classic supervised learning problem. And there are many types of classifiers and algorithms that can be used, but three are fairly common. So a decision tree is a simple classifier that's easier to get started with. It's a weaker predictor, but it's easier to explain why an account was flagged. This is helpful for showing compliance officers and regulators that there's no bias against protected groups. A random forest is actually an ensemble of decision trees. Each individual tree may be a relatively poor predictor, but the ensemble will be a strong predictor, at the cost of a loss of explainability why an individual may have been flagged in a certain way. Logistic regression calculates the probability that an account will fall into one of two classes, fraudulent or not. For that reason, we call it a binary predictor. It also may not be easy to explain why an individual is classified a certain way. Here's an example of an actual engagement done by pivotal data scientists to help a Bankcard processor uncover synthetic fraud. Before the engagement, the customer was suffering from disjointed data files that were difficult to work with, a very slow and manual workflow process that was unable to capture all the truly malicious accounts. But by examining large volumes of data, in this case we looked at 3 years or over 15 terabytes worth, and over 1,700 variables, we were able to tease out certain factors, such as the account open date and the number of credit line inquiries, and build those into a predictive model to find fraud. Many of these algorithms can be executed in parallel, but only if the data platform supports it. Models can be developed, tested, and deployed faster if we can do analytics in the database to run as many experiments in as short a time as possible. In-database analytics executed in a distributed computing environment is necessary for rapid data science, but in-database analytics depends on all the data being integrated into one place. Also, it's easier to address more complex use cases like finding chains of fraud with collaborators if the data warehouse can query and manipulate other data like graph or geospatial objects like it does with relational data using SQL. Greenplum is a massively parallel processing analytic data warehouse. It supports parallelization of algorithms across unified relational and non-relational data like text, graph, and geospatial objects in a single environment. This helps data scientists run more models in less time, which is especially important for applications like behavioral modeling at the individual level across large populations. To do analytics, Greenplum relies on Apache Madlib, an open source library of machine learning, statistical, graph, and math functions that provides distributed machine learning on large scale data sets. It takes advantage of the massively parallel execution engine within Pivotal Greenplum. Some data scientists also prefer to work in R rather than SQL. So for that, we offer Pivotal R, a package for the R client. It takes R function calls on the client, intercepts them, and translates them to the appropriate SQL, and pushes it down for processing within Greenplum. And of course, some people prefer to work with Python. That's also parallelized within the MPP engine within Greenplum. We have a number of resources on our website that describe how we apply analytics to other types of fraud use cases. Please take a moment and review them.